I'm Amber Rowden. I'm the community storyteller at Rainforest. That's Bridget Legault, the community manager at Rainforest. And I'm going to pass it off to the wonderful Ruth Ann, our co-host at Rainforest, to do an introduction.
Yeah, thank you for that. I am happy to be here representing the Edmonton Steering Committee for Rainforest Alberta. And I know there's a couple other members here. Gail is here, Aaron is here. If anyone else is here from Edmonton, give us a shout out because I can't see everybody. But in the spirit of reconciliation, we acknowledge, first of all, that we do work and play on the traditional territories of the Blackfoot Confederacy, the Siksika, Gaina, Piikani, Tsuut'ina, and the Iyakson Nakota Nations. I have those phonetically here, and yes, I should be practicing those more often. The Métis Nation, of course, is in Region 3, and all people who make their homes in the Treaty 7 region of Southern Alberta. For those of us in the Edmonton area, we acknowledge the traditional lands of the Treaty 6 territory of the Cree, Dene, Blackfoot, Saulteaux, Nakota Sioux, as well as the Métis. And these sacred gathering places provide us with an opportunity to engage in and demonstrate leadership and reconciliation. So thank you for your enthusiasm and commitment to joining Rainforest Alberta in doing so. That's really important in the spirit of writing relations.
What does it take to realize an idea or for a seed to sprout? At Rainforest Alberta, we know the answer is rooted in trust. Traditionally, Albertans have cultivated their ideas in established systems. Inputs that don't fit these systems are weeded out. Opportunities for growth are missed. But now, Albertans want a dynamic landscape that can evolve organically, like a rainforest. At Rainforest Alberta, we believe a culture of trust is the fertile soil where ideas grow. Our budding innovation ecosystem is a network of relationships pulling each other up as they push forward in their own field. Trust breaks down barriers. An open, inclusive network increases collaborative innovation. Successful breakthroughs inspire new ideas. A cycle begins. Rainforest Alberta is a movement to amplify trust by cultivating honesty, inclusion, and accountability. How? Our social contract holds us accountable to demonstrate trust across the province. We meet to have honest conversations around collaboration. This leads to more inclusive spaces for everyone to fearlessly build new ideas together. By raising the standard of trust, Alberta's ideas, talent, and resources can be evergreen. Visit rainforestab.ca to sign the social contract and start growing together.
As a social innovator, it's that social contract that initially attracted me to the rainforest. And I know Amber will put that link in there. If you've not already done that, please go look at that and consider signing that. We are talking about the 6 pillars here. We talk about culture, we grow leaders, we share resources, we offer engaging activities within the infrastructure, and we model psychological safety and inclusion and that trust that we were talking about. So we just want to be respectful here in our communications. So connect with private messaging that's available. Put your camera on if you want to. It's always so much more engaging. I mean, especially when we're in the small rooms, of course. Feel free to ask lots of questions. I will help monitor the chat. And yeah, check out the recordings and everything that you want in Slack, and we'll be connecting there as well. Ta-da.
Thank you so much, Ruth Ann.
My pleasure.
All right, so today, actually, as Ruth Ann mentioned, feel free to put your LinkedIn in the chat, and if you're new to Rainforest, what you're looking for in terms of connecting and how you can help each other out. So to get started today, I'm very excited. Matthew Lowe is the CEO and co-founder of ZeroKey. He is a native Calgarian with a passion for technology and entrepreneurship. As the original inventor behind ZeroKey's smart space technology, Matt holds over 26 patents and is responsible for taking a back-of-the-napkin idea and building it into a rapidly scaling tech company. Prior to founding ZeroKey, he worked as the head of information systems at LWOL AG, a major manufacturing company with global revenue of over $2 billion US. Over the course of his career, Matt has contributed to several mega projects, including Linux and Arduino. He has also acquired many accolades, including winning the machine demo competition at the renowned Collision Conference. And with that, I'm very excited to pass it over to Matthew Lowe, who will be taking us on a virtual tour of ZeroKey.
Awesome. Thanks, Amber. Appreciate the intro. It's great to be here and chat with everyone. As Amber mentioned, I'm CEO of a company called ZeroKey. We're a startup based in the Calgary area. We're a little over 4 years old at this point, and we've been growing fairly rapidly, especially over the last year. I think since January, we grew about 50%. So we're definitely experiencing an accelerated trend. But yeah, we're here today to do a little tour of the facility and show you a little bit about our technology, and hopefully there's some great questions at the end. I think our tour is only about I think 18 minutes long or something like that, so there should be some good time for Q&A. So without further ado, let me share the screen here and get into the tour.
Hey everyone, my name is Matt Lowe. I'm CEO of ZeroKey, and today I want to show you our new facility. Come on in. So we built this facility last year. Towards the end of it, we are still getting up and running, if you can believe that, and have done a couple rounds of renovation since. And so love to show you what we've got in store and a little bit about what we do here, and hopefully you enjoy. So right up front, we have our conference room, boardroom, nice little display. Usually we'll do fun things when new employees start. We'll throw a little blurb or message up there for them, and kind of an interesting way to welcome people to the company. If we go into the back here, it's kind of our bullpen area. We're still under kind of hybrid COVID protocols. So we got, I'd say, about half of our staff working from home still and about half in the office. We're at about 40 staff in total. So about 20 people here on a regular daily basis. Growing every day, which is great to see things get back to normal. So we have kind of a blend of software and engineering that takes place here, as well as some of our sales team is here in the bullpen. This is almost at capacity. I think we've got 1 or 2 stalls left open, but other than that, we're running a little short on space, so we've just finished a renovation to add a bunch more desks over on the other side, and we'll get to that in just a minute. More software development offices and hardware offices along the sides here, but let's go into the back and I'll show you some of the equipment and stuff that we do back there. So this might look like a big open space, but this is actually one of the biggest features of this facility for us. Living the early days of the startup life, we came from a very small space, roughly 4,000 square feet, which with this many people, you can imagine how tight that was. And we never really had the space to test our system at scale. We always were forced to rely on customer facilities, which is obviously a bit of a challenge. So moving into this new facility last year, 20,000 square foot facility has really given us the opportunity to start to test at larger scales, which are the same types of environments that our customers deploy in. So a lot of factories, warehouses, that sort of thing. Eventually we're going to have a fair amount of warehousing here as well. We're just really still moving in, so a lot still going on. But let's go over to the production and R&D side, and I'll show you some of the really fun toys. Actually, before we get there, I'll point out, so So our technology usually gets installed in the rafters or on the ceiling or high up, and that gives it usually the best vantage point. And so we do have a skyjack here that we use in-house all the time. A lot of our deployment team will use that to go up and tweak things or adjust things, throw new versions of hardware, that sort of thing up there. So we're sort of coming in from the back end, but this is where we do a lot of our prototyping, low volume production, that sort of thing. We've got a SMD line, just a small kind of really rudimentary SMD line up there. As well, we've got some rapid prototyping 3D printers and whatnot that are pretty neat. We'll get into to see that. And a whole bunch of other equipment that we use in the R&D process. So let's go take a look. So this is kind of our real basic SMD line. We've got here a stencil printer, which is pretty decent because it's semi-automated. We've got some 2 pick and place machines. And then right behind that, we've got a reflow oven. We've got another reflow oven over there too. And then a PCB cutter just down at the end. So this allows us to do like really prototypey type builds. Anything that's low volume, you know, say less than 20,000 pieces, we could probably do in-house here. But for most of our stuff, a lot of the higher volume mass production stuff, we're still going outsource, you know, relying on vendors that are experts in that. We're experts at the design, but the production here really just to shorten the timelines on prototyping and R&D. So come on through. Then along the side here, actually we do have, you know, a number of electronics workstations. We do a lot of hand soldering for prototypes, and we'll tweak, you know, filter values and stuff like that on the electronics. So all of that gets done in-house. You know, we're basically set up to do soup to nuts, everything we need to do for building prototypes or engineering samples, and, you know, right up to the point of the handoff to mass production. So I'll take you guys inside the 3D print lab. This is actually a new room. Come on in. So it's actually a new room. We just had this built, I think it was just finished a couple weeks ago. But we do a lot of in-house rapid prototyping. And, you know, a couple key features. We've got a bunch of FDM 3D printers here, SLA 3D printer back there. Really allows us to do rapid parts. You know, they're not necessarily exactly like an injection molded part, but they get us a good form, fit, and function test. But one of the keys of this whole room, or this whole of all of our 3D print capabilities, is this HP Jet Fusion printer. This is one of the newer printers for us. It allows us to print in a nylon-like material that gives us functional strength parts. And so that's really big, because with the FDM and the SLA printers, usually you're dealing with parts that are weaker in strength, and there's some limitations in terms of the geometry of the part. This one here basically is full color 3D printer. You don't have any of those limitations, and the nylon-like material is a functional strength part. So you can actually print what will actually come out very similar to an injection molded part. So love this guy. It's obviously a bit bigger of an investment than some of these other pieces of equipment, but one that we use all the time. I'm going to quickly pop through the hardware lab. So this is one of the newer rooms we built as well. This is where a lot of the hardware engineering goes on, electrical design, mechanical design, and testing. Basically everything we need to produce parts originates in this room. So this here is actually a piece of equipment we built in-house. It's fairly sophisticated at this point. I think we've been through a number of iterations. Essentially, we've got here a linear rail that allows us to move this stack very, very precisely up and down the rail in arbitrary patterns. And then as that moves, we're able to measure exactly where that is relative to this other stack on this end. So that gives us the ability to really put our technology through its paces. Our technology, which allows you to locate things in 3D space, well, fundamental of that is actually knowing how far 2 points are away from each other in 3D space. That's the very fundamental, and then you build up from there to get kind of a 3D position. So this allows us to test the fundamentals of our technology in a very controlled way with a ground truth system that's extremely accurate. We've got lasers, rotary encoders, whole 9 yards up there. It's all controlled through a bunch of scripts and tools running on the PC, and we've got a bunch of fancy software-defined radios that are kind of tying the whole thing together. So it's a really neat piece of equipment that we built in-house, and it really is the reason our technology has been able to advance to the level it has, where we're 100-fold more accurate than anyone else in the world. And I should point out, one of the key things about this facility and the reason we got this space was the length of this wall right here. So we're in the process right now of speccing out, designing, and building a rail that'll actually run from the wall all the way here on the north side, all the way down to the south side. So it's roughly a 35-meter run, which will be a big upgrade, obviously, from what we got here. All right, let's go back up front. So we're getting into the firmware side of the building. Again, a lot of shared offices here, just given the number of people we have in this space. This is actually our scrum room, and it says testing on the door, but let's see if we can't sneak in. So this is our scrum room. Obviously whiteboard walls all the way around. Software teams usually meet here about once a day. Talk about, do their stand-ups, also, solve all the complex problems. This is probably where, all of the main technology was built, or at least since we moved here. And it's definitely one that I'd say probably the most active building in the whole facility. As we get further through, we've got the firmware team over here in this office, and then we got the deployment team here right beside me. And that brings us to the fun stuff. You'll see we've got a kind of a rec area here for the employees. Pool table, of course, a couple arcade games. And at one point in time, we'll have an Xbox or PlayStation on the TV there. This is our kitchen area. Of course, we've got beer on tap, kombucha right beside it, for those that prefer that. Kind of a good area just to take a load off, relax, and take your mind off work for a little bit. So I wanted to just quickly stop by our ZeroKey Museum, a little display case that chronicles the trajectory of our technology over the last few years. One of the interesting pieces here, this is one of our very first prototypes. For those of you that are into electronics and whatnot, you'll recognize some of these components. These are an off-the-shelf Arduino with a couple SparkFun boards and a couple other sensors, just all tied together on one of our PCBs. I actually remember designing this PCB back in the day, learning Eagle, which was a fun experience. So this is the very first version, and I'll jump right to the end of the spectrum to our latest version. This is now our mass-produced injection molded unit. It does everything this does and quite a bit more, all in a little case, plus actually has a battery in there too. And let me take out this little clip so you can see the actual scale of this. So this little guy here, we can track and locate in 3D space to basically the thickness of your thumbnail. So 1.5 millimeters in 3D space, which is about 100-fold improvement over the next closest technology, which would be ultra wideband. Ultra wideband's accurate to about 15 centimeters. So quite the revolution in the industry. And it opens a lot of use cases that are pretty interesting, things that we haven't even thought about until we go talk to a customer and they say, hey, now that you can do that, guess what we can do? And so it's a really interesting learning process for us as well. And we'll get into some of that in the demo, and you'll see kind of what that accuracy will do. But before we get there, just kind of think about in your mind a lot of these different industrial environments, like whether it is a factory, whether it is a warehouse. All of the processes, the manual processes that are human-driven, are for the most part analog, and they're not captured within a digital platform. So, for example, in a warehouse, if you sent one of your workers to go to a certain aisle and pick a product from a bin, you may know that you sent him there through some sort of warehouse management system, but you don't actually know where he is en route. You don't know how long it's taken him. You can't really digitally validate that he's even gone to the right place, which leads to a lot of the errors in supply chain that we see every day. With this technology, you can now know exactly where that person is, and not just at one point in time, but over time. So you're actually getting a digital picture of this analog environment. So I often describe it kind of like stepping into the matrix. Now you know where everything is digitally, and you'll really see that to the nth degree when we get into the demo. And then moving further down the line here, we've got some kind of in-between versions. Some of these were printed on those FDM 3D printers you saw back there. And then right at the bottom is a new line of products we have, which is actually an intrinsically safe version of this. So they're deploying this in the field where there's explosive gases, explosive dust, some chemical plants, that sort of thing. But then we can locate people in those hazardous environments, let them know if they've gone into a dangerous area, that sort of thing. So there's really quite a few use cases, and these are really the main product lines from us right now. So without further ado, let's jump into the demo and go take a look.
Awesome. I'm just going to pause the video real quick there to fill in a little bit. We ended up splicing in one of our demo videos. We had shot some footage actually of a demo at our facility here because we've got a really nice workbench set up. And then the next day realized that the camera wasn't recording, or there's some sort of corruption or something. So we spliced in a different demo video here, but effectively the same use case we're going to show. But before we get into it, I just want to kind of explain a little bit about what's going on, and maybe get into a little bit more detail on our technology. So the one thing I haven't yet really mentioned is exactly what our technology does. So our technology is what's known as a real-time location system, and it allows you to locate where things are in 3D space. Our system is based on ultrasound as a fundamental technology, and that allows us to get really, really high accuracy. So our real claim to fame is that we're the most accurate wide area location system in the world. And so when you think about things like location systems that we all know about, like GPS, for example, that's something, GPS is a really, really great technology. And, we actually incorporate a lot of the same fundamentals as GPS, but GPS being based on radio waves and radio frequencies causes it to be a little less accurate, or I guess quite a bit less accurate. And usually you're talking about accuracies of around 4 meters. And we've kind of all experienced kind of the downside of that when, maybe you're driving downtown in your car and your car is, skipping to different roads, or it hasn't quite locked you onto the spot where you are. That's really just kind of the positioning algorithm trying to make sense of this, low accuracy source of position and kind of figure out where you are. So our technology, on the other hand, gets down to that 1.5 millimeters of accuracy that I mentioned, and that's in full 3D space, so X, Y, and Z. And kind of the advantage of that we'll see here in this demo is now you can actually understand context to what all of these different movements are. And you're no longer just talking about locating where a person is. Now you may be getting down to more detail, like where are their hands, where is a particular tool. And so that's what we've got set up here in this demo. We're actually doing tool tracking, part tracking, hand tracking through an assembly process. So on the right side of the screen here is a video of what's going on. But it's important to mention our technology doesn't use cameras of any sort. So that's actually really important in a lot of these environments that are often, there's strong labor unions or privacy concerns, or even security concerns in certain facilities. So the camera is really just so we see what's going on, but it's not actually part of our technology. And then as you move a little bit to the left here, you see kind of this, what looks like a video game screen with the bins in front of it. This is what we call a real-time digital twin. So this is the digital representation of what we understand is going on. And this is where you can really see the power of the technology come through. Because as he works through this process, it's going to exactly mirror that in a digital sense. And then if you go one step further to the left, you're actually going to see the outputs of that. What are the insights that we're deriving from this information? And it's actually going to step through this workflow tracker in real time automatically. So that means the computer system is now understanding this workflow. It understands and it's gating every step in that workflow to make sure that it's been done correctly, that there hasn't been an error, you haven't grabbed the wrong part from the wrong bin, that you've torqued the bolts in the correct sequence, which is kind of an interesting use case. It might surprise a lot of people, and I often kind of get this shocked look when I explain this, but in the manufacturing world today, when you do have kind of a small scale assembly like this and you've got a manual assembly process, there is no technology that actually validates that you've torqued a sequence of bolts in the correct sequence. A lot of the digital torque wrenches these days can validate that you've torqued the correct number of bolts, or that you've torqued them to the right specification. But it actually doesn't know the 3D position of where that torque wrench is activated. So it can't validate that you've done it in the correct sequence. And this is actually the source of a lot of recalls in the automotive and aerospace industry. And so areas where, these types of mistakes have a high impact, like if a plane falls out of the sky, that's a big problem. Those are the types of scenarios where this data is invaluable, and where you can actually start to really change not only the workflow to be more efficient and with higher reliability, but you can also catalog and digitize that assembly process so that when you come, say you have an issue down the line, perhaps a certain vehicle has had a failure and you're trying to figure out if you want to do a recall, you can go back, look at the assembly process for a particular vehicle and say, was this an assembly error? And if it is an assembly error, can we then identify that pattern, go back through all of our historical records and say, what other vehicles have the same problem? And maybe we can go recall those specific vehicles before, that fault has had a chance to really cause an accident or something along those lines. So there's a lot of different use cases, but, we're not limiting, our technology is not limited just to manufacturing. We apply it very broadly to warehouses, to even oil and gas environments such as drilling rigs. We apply it to virtual reality. Anytime you need to digitize a real world process, a physical process, and understand where things are, our technology can help you out. So without getting too much more into it, let me play the demo video here, and we can see what this looks like in practice. I just wanted to pause it right there because this really highlights a core capability that we offer. So in this particular case, the person in the demo here actually made a mistake on purpose, but you'll see that the system detected that in real time and let them know at that exact moment that they've made an error, which is so critical. We actually had a customer, there's a big automotive, everyone knows their name, and they had a problem on their assembly lines. And they ultimately ended up scrapping several hundred vehicles because by the time they had detected the error in the assembly process, it was actually more expensive to go and fix it than it was just to go and build new ones. So this is a common problem. It leads to all sorts of faults, whether they are and impacts, whether they are economic impacts or whether they are loss of life or serious injury. So these types of situations and use cases are very important to improve and bring into the context of a digital platform. So just wanted to point that out. Cool. So that was the end of the demo there, and in the end of our short tour. So I'd love to open it up to some questions, and happy to chat if there's any comments on that.
Awesome. Thank you so much, Matt. There's a couple of questions in the chat. Just see if I can find them.
We could start with Peter Zamber, the 3D printer that uses nylon for strength. Can it replace white metal forged parts for small batches?
Let me see.
The examples, bike parts, little items that, from products that are out there in the marketplace where the manufacturers kind of left them behind.
Yeah, I mean, that's definitely one of the strong benefits. Nylon's a great material. Obviously it's not quite up there in terms of like some of your aluminums and steels and whatnot, but definitely, I mean, we use it for all sorts of functional strength parts. So I don't know, I guess it would depend on the particular part in the use case in terms of,
Of course.
Yeah, what your requirements are. But yeah, It's been a game changer, to be honest. That 3D printer, the reason we made the investment, it is quite expensive, but the reason we made the investment, when it came into the market, we were just getting prototypes made constantly by a couple of companies that had one. And we realized it was actually very economical to bring that in-house. But we use it for like not just in-house prototypes, we'll also, if we work with a customer and we ship kind of an early version of our technology, instead of making the $50,000 to $100,000 investment in injection mold tooling, we'll go and print those and send them off to the customer. So I guess Mike Webster asked if we could give an idea of the typical size of our customers. Generally, we work with some of the larger companies in the world, companies like Volkswagen and Volvo and whatnot. We do have some smaller customers that we work with as well, but this type of technology really lends itself well to problems of scale. When you can start to gain efficiencies on a small problem that you do lots and lots of times, or that you have going on in parallel in a lot of different locations. That's where you get to really realize significant benefit. So typically we work with bigger companies, although like I said, we work with startups as well that, have said our technology plus your technology gets us that much further down the road. So we're really happy in those types of situations where we can see kind of the, next generation of emerging technologies benefit from what we're doing.
Awesome. V, did you want to ask your question?
Yeah, thanks. I see on ZeroKey the gateway to Industry 4.0. Can you give us a quick overview of what Industry 4.0 is, and
Sure.
Where's Alberta, do you think?
Yeah, so two great questions. So Industry 4.0 is kind of this umbrella term, that industrial IoT falls under it, digitization in general falls under it, but it is really about a more connected industrial environment. And you may have like motors that now have outputs that are dumped onto a network, and you're logging those. You may have integrated equipment where one set of actions leads to a different set of outcomes. And so it's all about that digitization and really adding a layer of intelligence from the digital side. So, if we went earlier in time than Industry 4.0, we may have had a lot of, like PLCs and logic controllers and stuff like that in these environments, but they weren't necessarily connected in an intelligent way. You usually had to have operators and technicians still drive a lot of the decision making. And so Industry 4.0, at least what it's supposed to be, is exposing a lot of those things in the industrial environment and giving operators the ability to have that digital layer of intelligence. And so our technology, when you look at those environments, as I mentioned in the demo, they're extremely analog. Most of the things that go on in a factory or in a warehouse are not digitized. You probably have 99% information loss. And so it's very, very hard to have that intelligence layer if you don't know what's going on. If you don't know that you've sent Tom to the factory, but he's stuck at some sort of roadblock behind a whole bunch of forklifts that are going through. You don't really know that in a kind of a traditional factory, but in a modern factory, if you've got that level of digitization, you can start to identify those faults and those hiccups or those bottlenecks, and in real time or through post analytics, solve that through that information. So that's kind of the promise of Industry 4.0. Now, where is Alberta in that? It's actually a very interesting question. Alberta has traditionally been very, very good when it comes to technology in some of our traditional industries like oil and gas. We've got some of the best oil and gas technology in the world. And a lot of that, you look at companies like ZI and whatnot in the Alberta ecosystem that have really advanced technology, digital solutions that are bringing more and more technology into these very traditional environments. So I think in our core industries, we've done a fairly good job. Are we completely modernized? Absolutely not. I mean, I think everyone who works in the oil and gas industry, for example, knows that a lot of stuff, a lot of very mission critical stuff is still done on spreadsheets. And I think I see enough Lotus 1, 2, 3 installations in the oil and gas industry still that I could never claim it's fully modernized. But in general, our Alberta ecosystem is, really good. And I'd point to companies like Adabotics and whatnot. And we have a lot of these types of industrial solutions that are becoming more intelligent. And I say it's definitely something where we've got a great niche in Alberta, at least for the industries where we have a lot of that domain expertise. And we're seeing that kind of flesh out now that, there's this big trend in the startup ecosystem and things are moving in a technology direction. I think we're just going to see more and more of that, like, core knowledge get translated into innovative solutions. So I'm really excited for what the future holds on that front.
Thanks, Matthew.
Mark, did you want to ask your question?
Sure. I'm looking at 3D printing house foundations, and I want to do it at the end of an 80-foot boom that articulates. And one of the challenges here with the print head is controlling its position. And it just off the top of my head looks like this might actually be able to do that. What's your feeling about that?
Yeah, absolutely. So already when it comes to robotics, that's a big area of integration for us. So you can throw a sensor on the end of a boom and locate that very, very precisely. We do that in indoor environments right now for what's called autonomous guided vehicles. Basically, kind of like imagine a forklift without a driver. We'll add navigation capabilities to those in warehouses. We also do it with forklifts for safety purposes, but also for automation purposes. So I don't think there's any reason you couldn't attach it to the end of a boom and track where that is.
That's pretty interesting. Thanks.
Thank you.
Awesome. Thank you. We have a question from Catman. How do you cover so much space with ultrasound, and how much space can you cover?
Isn't it too strong near the transmitters? So the way our system works, there's a couple different configurations of it, but basically we set up our infrastructure in a given environment, and that's what we call anchor devices. And so basically you place those every 20 to 40 meters, give or take, within an environment. And once you have those in place, then you can start to do your tracking. The advantage of this is that you can just kind of add more and more anchors to cover larger and larger spaces. So it's actually really, really scalable. We can do large facilities that are millions of square feet. We can do multiple floors. There's really no limitation to the form factor in that sense. And then when it comes to the signal being too strong, I'm not entirely clear on what that question means, but our signal is tuned to be a very specific level, and that's to be within all of the standards around the world in terms of what's allowed to be in these environments for ultrasonic signals. So we fully comply with a whole host of standards around the world. And no, we don't really have any issue with that being too strong because we can control it very precisely.
Awesome. So there's a question way up in the chat. I finally found it. It's from Curry. He asks, what's the difference between ultrasound versus LiDAR? Is LiDAR less accurate or more cost prohibitive? And I don't know if I said that right, but it's LIDAR.
Yep, LiDAR. No, that great question, and that was the right pronunciation. So yeah, LiDAR can be very precise. And actually that's maybe gets to a more fundamental question. But in terms of LiDAR, the expense is really high. And in terms of what you're doing, like if you want to track a whole bunch of devices, usually it's prohibitive to have LiDAR, and there's all different forms of LiDAR, like, especially self-driving cars these days are deploying LiDAR, but you also have LiDAR type devices that will like scan an environment, build a 3D print cloud, that sort of thing. Probably too many differences to get into the exact details. LiDAR can be very precise, and it also is very expensive. And fundamentally, the big advantage of using ultrasound is that as opposed to a signal transmitting at the speed of light, which is what radio frequency and light transmits at, which is 3 million meters per second, you've got an ultrasonic signal which transmits at the speed of sound, which is roughly 340 meters per second. So you've got several orders of magnitude slower in terms of the signal. And the advantage being that you can then identify that signal with much lower cost electronics. And so we're talking the difference of, what could be tens of thousands of dollars to hundreds of thousands of dollars is how much more expensive these other technologies would be. So it really opens up a whole bunch of use cases that otherwise wouldn't be practical. The other thing with the LiDAR solutions is that not the really high quality, high accuracy ones that are fully 3D are not real time. Usually a scan takes 30, 40 minutes. You can get some real-time LiDAR, but then there's always trade-offs and capabilities. And then on top of that, it's not a really scalable solution because you've got things like obstructions that get in the way. And I mean, there's a whole host of specifications that they're a little different. The closest technology to ours in terms of competing technology is a technology called ultra wideband. And it uses radio free, it's kind of like GPS using a particular frequency, but it's still radio frequency based. So it means signals are transmitted at the speed of light. That means their equipment is more expensive. And also because it's the speed of light, they don't have the same level of accuracy in identifying those signals, which leads to a lower accuracy in terms of figuring out where things are. And that's really our claim to fame. We operate in the niche of hyper accurate 3D location.
Awesome. Oh, Ross, did you want to ask your question?
How does the technology work outside, if at all?
Yeah, so works the same way as inside. We've got a version of the products that are IP68 rated. And so you simply deploy them in the same fashion. The one limitation and what we frequently run into in outdoor environments, like we still need a certain density of anchors. And so if you're not in an outdoor environment with nothing to attach them to within that density, then you're looking at putting up poles or posts or tripods or something of that nature. So that's usually where we bump into issues. And frequently when it comes to our deployments, we usually deploy around the perimeter of a facility so that you've got tracking of forklifts as they get material and whatnot. But we usually don't do extended outdoor deployments. And usually for use cases that are highly outdoor, there's a lot of great solutions from Calgary companies like Novatel that deploy what's called RTK GPS, which is pretty precise and pretty accurate for outdoor use cases.
Okay, thanks. Yeah, I think that clarifies it a little bit. I was just curious as to if you had an outdoor site, how you could set that up so that it is tracking all of that within that space, or even feasibly the scale of a neighborhood as well.
Yeah, so we don't have outdoor deployments on that scale, mainly for the issue I mentioned, because you do need a certain density of the anchors. And so, there's a lot of our customers that have looked at hybrid solutions, and we've got some hybrid solutions kind of in our pipeline that might be coming out in a couple of years. Okay. But yeah, generally we don't play in that space too much.
What is the density of the anchors like?
Yeah, so roughly, depending on the performance you want, every 20 to 40 meters, you need one anchor.
Okay, cool, thank you.
We have a couple more questions from Catman. So each anchor transmits an ID like GPS satellites, but doesn't noise prevent your system from working?
Yeah, so each anchor is uniquely identified, and they are, there's a couple of components to the system I haven't really talked about, but there is a back channel, an RF back channel that our technology uses. So the ultrasound is used for positioning, and the RF is for communication and data backhaul. And so we're able to identify our nodes both over the RF and the ultrasonic side. And yeah, it is somewhat similar to GPS. What you're talking about is in GPS, they use a thing called code division multiple access, or CDMA, and we use something quite similar. And then the next question, doesn't noise prevent your system from working? So no, not normally. So we transmit at a specific frequency, that's beyond human hearing as well as the ultrasonic range. And so, there's not actually a lot of natural sources of ultrasonic noise. And one of the advantages of being in the ultrasonic frequency spectrum is that the wavelength, and I'm getting a little into the engineering side, but the wavelength at that frequency is actually much shorter. And what that means is that the signal attenuates faster. So even if there are sources of ultrasonic noise, they fade out. And we all experience this every day. If you got a neighbor that plays loud music, you hear the bass come through a lot more than you hear the high end. And so now imagine a signal that's even higher up in that frequency spectrum. If there are natural sources of ultrasonic noise, then they die out very rapidly. But for the most part, no, we're fairly immune to sources of noise. And in fact, we get called into most of our customers' environments because they have noise problems with other technologies. So ultra wideband, as I mentioned before, as a radio frequency based technology. And what happens is they suffer from reflections off of metal objects because it is radio waves, and those basically bounce around off of metal like light off a mirror. And that causes all sorts of degradations in their system, particularly in indoor environments. We don't have that same problem because we're relying on acoustics for our tracking. And so we actually have a much more robust technology in those challenging environments.
Awesome. Thank you so much, Matthew. Well, we're going to get into breakout rooms and keep the conversation going. So Bridget, if you want to get those set up, we'll get those going. And then we'll come back for announcements at 12:55.
Great. We'll see everyone in a bit.
Bridget, do you have a dog?
No.
No pets?
No pets. 3 kids is enough.
It's a lot of
Desperately want a dog, and I just say no. I can't handle it anymore. Maybe when they're a bit, I told my daughter I could give her a fake pet to play with, like to care for a few weeks and see how she does, but I'm sure it wouldn't go well.
My neighbor had a golden retriever, and my kids wanted a dog. And I said, if you can walk the neighbor's dog for a month, we will get a dog. So of course it lasted a week, and it didn't even last a week.
There we go.
Yeah.
All right. Well, welcome back, everyone. Before we get into announcements, I just want to give a great big thank you to Matthew for sharing ZeroKey today and for his time. It was an amazing tour. And yeah, thank you everyone for joining us as well. So I will open the floor to announcements.
Yeah, thanks for having me, Amber, and everyone. Hope you enjoyed it. And if there's any more questions, just matt@zerokey.com if you want to chat.
Thanks, Matt.
That was very cool. So my name's Gail Powley. I'm president of Technology Alberta, as well as a volunteer with the Rainforest. And I have 2 announcements that I have shared in the chat. And so the first one is just about the Rainforest Connector that's held in Edmonton. It physically was held at the Research Park. Now it's held virtually. The theme, it's once a month, every 3rd Thursday, so Tuesday, excuse me. So it's next week at 4:30. And the theme is innovation in construction. And we have 3 entrepreneurs, one large one being Chandos Construction, which headquarters in Edmonton, offices across Canada, largest B Corp contractor in North America. And B Corp is the rainforest kind of values, where it's all about social and environmental responsibility. So they're going to talk about their practices, how to be a B Corp, as well as there's Correct AI, which AI in that space, as well as Robolution, robotics in construction. So hope everyone can join us. Again, the link is on the Rainforest website, but as well, I shared it in the chat, 4:30 next Tuesday. And then my second announcement is on the Technology Alberta side, that we just today opened up the registration for the Next Level Careers program. We open it up for both companies and career professionals that are who want to work in the tech industry. So we have a small amount of funding that's given to us through the government of Alberta to seed a small project so that you can work together with someone, the company and the career professional can work together on a sample project, and with the hopes that if it's a great fit, that person would be taken on full time. So the registration will be open for the next 2 to 4 weeks, and projects will be posted in September. So thank you, Amber and Bridget.
Hi, Gail. I was talking to Lisa Safal. She's here in the room, and I suggested that you two should connect.
Oh, excellent. Thank you so much, Stephen. And Stephen and I have worked together years ago with the BEST program, Bridge for Engineering, Science and Technology Talent, which I ran through Calgary and Edmonton. Thank you, Stephen. I appreciate that.
My pleasure.
I put an announcement in the chat for the Great Alberta Pitch Marathon with 100 startups pitching. It will be a really exciting day, lots of partners involved, and I think they're still looking for a handful more entrepreneurs. So check out the link there.
Very cool.
And there's 9 days left to get your Harley ticket and help the Children's Hospice. Really good program. And we have a ride starting at the Children's Hospital tomorrow. That's a group, and it's called Ride to the Rockies. In case you're a motorcycle rider, and if you're not, then just come out for a donut and say hi. And thank you to everybody who have bought a ticket so far. There's, odds are awesome now because the ticket sales are fairly slow, and maybe you'll just get $20,000 or a Harley Davidson, and you'll be helping out the kids. Thanks.
Awesome. Thank you so much, everyone. All right, it is the top of the hour, so you're free to go. Thank you so much for joining us today. It was great to see everyone, and we will leave the room open. But yeah, thank you so much for joining us, and see you next week for a tour of the Platform Innovation Center.
All right, thanks.
Yeah, little schedule shift there. True Angle wasn't able to do their tour next week, so they will be doing it in September. And we'll have a little sneak peek into the Innovation Center next week instead.